Ideal gas equation and applications of this equation. Ideal gas equation derivation of PV is equal to nRT and its application in calculation of relative molecular mass and calculation of the value of R. This is the syllabus portion. Let us derive the ideal gas equation. By using Boyle's law, Charles' law and Avogadro's law, we can derive the ideal gas equation. Boyle's law. Volume is inversely proportional to pressure at constant temperature. Equation number 1. Charles' law. Volume is directly proportional to temperature at constant pressure. Equation number 2. Avogadro's law. The volume is directly proportional to the number of moles at constant temperature and pressure. Combining the equation 1, 2 and 3, we can write V is proportional to N and T and inversely proportional to P. Equation number 4. R is a constant known as universal gas constant. Removing the proportionality by using R, V is equal to R N T by P. On rearranging, PV is equal to nRT. By using this equation to solve a problem, molecular mass, an assignment is given and another assignment for calculation of R. Determine the values and send the answers. Next is kinetic theory of gases. Van der Waals equation, that is P plus A by V square into V minus B is equal to RT for 1 mole of a gas. Numericals not required. This is the portion syllabus. Van der Waals equation. Let us know that what is meant by an ideal gas and a real gas. Distinguish, question can be asked, real and ideal. An ideal gas means which follow the equation PV is equal to nRT. That is PV by nRT is equal to 1. Therefore, for an ideal gas, the value of Z, that is PV by nRT, is considered as Z, a value which is equal to 1 for ideal gas. Therefore, result is equal to unity and is independent of temperature and pressure. Then, what is meant by real gas? The value of PV is not equal to nRT. That type of gases are known as real gases. Therefore, the value of Z for real gases is not equal to unity. It is either greater than 1 or less than 1. That is, Z value can be greater than 1 or it can be less than 1. The deviation of real gases from ideal behavior depends upon 2 factors, pressure and temperature. Van der Waals made necessary corrections in the gas equation PV is equal to nRT, and a new equation known as Van der Waals equation is formed. For that, 2 important factors what he did correction is regarding volume correction. We know that in a container, if a gas is present, the volume of the gas is mentioned by the volume of the container. For example, 10 liters of gas or 9 liters of gas, mentioning that the volume capacity of the container in which the gas is taken. Van der Waals determined that the gases present in that container not fully occupying the full volume. Actually, these gas particles are minute particles and if they are actually occupying a portion of that container and the rest of the portion only the volume we have to consider. That means volume of the container is by applying a correction called a factor B. This is the volume, actually only real volume. These are all the particles present which is move around inside the whole area. Therefore, we say that this is the total volume. It is not actually total volume. A volume should be reduced. That the volume of the gas should be reduced, and that will be the volume. Therefore, let us see the explanation. The molecules of gases are finite size and possess definite volume. The actual volume of a gas should be less than the volume of the container in which it has been placed. We consider this volume, that full volume, but actually that is not the volume. This is the volume should be considered. If V is the volume and this volume is of the particles occupies B, V minus B is the actual volume. Now, the actual volume of real gases can thus be obtained by excluding the volume occupied by the molecule. This is the volume to be excluded. Van der Waals introduced a correction factor B for 1 mole of a gas known as excluded volume to account for the space diminished due to finite size and finite volume of the molecule. The excluded volume depends upon the nature of the gas. Fill in the blank question. If V is the observed volume of 1 mole of a real gas, then actual volume or corrected volume of the real gas is given by corrected volume of a gas is V minus B, that is for 1 mole of a gas.